What's up, man?
How's it going?
I'm doing great. So I like the shirt.
Yes.
We're back.
It's been a bit, yeah.
What's going on? Why so long? What's your problem?
Well, we had Ignite, which was really exciting. So that took up a bunch of September. And if you haven't seen the content around Ignite, please go and see it. There's a blog post with all the videos and the sessions and stuff. So that's been that. And then we're going to be making a bunch more in the next few weeks.
We've already seen this guy before. Many years ago.
Yeah, back in 2012 January for C++ accelerator massive parallelism, right?
Excellent. C++ Ant, man. So Hasibur.
Yeah, so hi, I'm Hasibur, engineer on Service Fabric team, and I have worked on a bunch of Service Fabric components, and I'm here. I'm fortunate to be with you guys. And
what are the bunch of components that you worked on?
So I joined back in 2015, April 18th to be precise. And then so I started with when you install Service Fabric, right? So on the right side of your desktop, you see there is a small tooltip icon there, right? It says when you right click start Service Fabric cluster. So that's the first thing that I worked on.
Okay.
The small icon. So basically I started with the developer tools that I worked on. Then I got onto the, so we were about to do public preview, and then we were doing the designing and then API designing of the programming model at that time. So I got onto that. Then I got onto the Actor framework. Then so Actor is a stateful service. So that the default state provider is the key value store state provider we have. So then I got onto the stateful services key value store. Then I started working on hosting, and then on the containers. So it's been like different things I have been
So we can ask you a fair few amount of things that you'd be able to talk about.
Well,
and I mean, like some of these concepts we've cursorily touched on in other videos. So hosting, we spent some time with Raji discussing it.
For sure, but we were way in the deeper part of the ocean.
Yeah, we were discussing implementation of Service Fabric, but today we're going to take a different angle.
Exactly.
And we're going to discuss this from your perspective, the developer's perspective.
Well, sure. I mean, I think the first place to begin would be like when you're confronted with the choice.
Yes.
Right? I want to build a cluster. So I was building a cluster to do some very specific things. To me, it didn't matter if it was stateless or stateful. I didn't need any state. I really didn't. I don't need to pass state around my nodes. But for some reason, I chose stateful. Because I was thinking, well, maybe I'll use reliable collections to host the log files.
Sure.
Whatever. But so beginning at the beginning would be, so I'm faced with that choice. Can we talk a little bit about when I want to go stateful and when I want to do stateless, and how I can have control over instances with stateless? It's pretty. Even with stateful, it's a little complicated. You have to really get the replica and partition counts correct and understand the simple math behind that. So without further ado, let's talk about that.
What I've seen generally with people is you start with a service, right? So you say I have a service, and then when you come to the world of Service Fabric, and then you say, hey, there's an application type, and then it is a service type, and then it is a partition, and it is a replica, and instance. Okay, where does I fit in all that world, right? So if I can go to the board,
absolutely. That's all we wait for.
Good work, brother.
So generally, what does a service mean, right? Service is basically your code, right? Am I big enough?
Yes, a little bit bigger, please.
Okay, so
that's fine. We know what that word is, just for the others. Yeah.
So your code basically will be either your executable or it could be container, right? On top of code, you will have some configurations, right? So you will have config, right, that your service needs. You will have some data, either initialization data or something else, right? Then you would want to have some resources as well. Handwriting is quite awesome.
Not bad.
And generally, all of this will comprise your service, and then you would want to know it or refer to it by a name, right? So you will give it a name and you say, hey, this is my test service, right?
Yeah.
So you can just deploy it, it will work fine. But in general, you may want to have more than one instance of a service running, right? With exactly same configuration with some name change or something. So if you're a software, you know that when you have two objects of the same class, what do you call the class? You say it's a type, right?
Sure.
So what we say in Service Fabric, if you want to create multiple instances of it, rather than calling it service name, you give it a service type. You say, okay, service type name you would have seen when writing the service manifest, right?
Yes.
It could be, you can say my
Service type.
service type, right? In Service Fabric, if you make it this one, we call it Service Manifest. That's what Service Manifest is today. You may, so in general, when we say applications, right? So application is collection of one of more services, especially in the world of microservices. The way you architecture and design your application is always one or more services which has a different relationship among each other, right? So when you're dealing with multiple service types, you may want to collect them together and refer to them in a common way, right? And they may share some common thing, and that's why they are application, because they share something common, right?
Because the application itself is just a fully abstract type. It doesn't actually.
It's just a logical abstraction to a way of bundling your services together and able to refer to it.
Yeah.
So that's what in service is called application manifest. So if you would have written any application manifest, you will see that you will say import statements, right? So you gave the name similar to service type. You can have multiple instances of your application, right? And that's why we say application type. Think of it as a class type, and you can create objects of your class type which has different state in it. So it's similar to service type. We have an application type here. Then you will have multiple import statements. Import service manifest. You can have many of those, right?
Okay.
So these basically are the collection of your services that you have. Then you will have policies, right? Policies are the things that allow you to tweak the behavior of your services, right?
Yeah.
Then you have environment on top of that.
So those are the parts that are inherited to
Yes.
the entire application, which
So
might be common
environment,
across.
environment could be like users, certificates, right? Anything that is shared by your different services. And then policies include things like ability to override certain behavior. So for example, you have certain environment variable here, or it also allows you to behave as a template where you have certain parameters. And then say, for example, I am writing a service where I allow some third party to run their stuff, right? So they use my service as a template, and they can instantiate a specific configured instance of it based on their input. And that's where every time when you create, you take input from the user, put that as a parameter here, and then you instantiate your application or service with those particular parameters. So then this becomes like a class, and then every service that is running or every application that is running has a specific state based on the user.
Cool.
So in general, so this is very powerful in terms of it allows you so many different ways, right? So think of it as a hello world in C#, right? You start with the hello world C#, there's a bare minimum thing you need to run. But C# has a lot of capabilities, similar to the way we have application model. In general, you don't need environment, you don't need policies, you don't need any of that. You just need one instance of that. So it goes back and becomes your single instance of the service.
Understood.
So it's like you start with a particular and then you generalize yourself. And that's what Service Fabric application model allows you to do. Initially, it can become overwhelming for you because there are too many things to learn. So you can start simple, but then all of the capabilities that we have here is to allow you to deal with any sort of requirement in your application that you have. You can try to have it in many different ways, and that's what I mean. And all of this has come from over large years of experience when customers has come to us and asked us for different abilities to do things differently.
Absolutely.
So even though it looks complex initially, but it provides a lot of flexibility and capability.
I'm on my one box machine. I want 5 instances of my service. It's stateful. Let's talk about partitions
I
and
think
replicas.
partition probably may not be very popular in industry. What people are more familiar with is sharding.
Okay.
So in Service Fabric, since I just shared what does a service type, let me write it as service type means.
There we
So
go.
you can have instances of service type, right?
Yep.
You can say service type instance 1, service type instance 2. They are incarnation or instance of same service type. Think of it, this is a class.
Service type is like your blueprint to your class.
Yep. And every instance of a service can have partitions. So it can have partition 1, partition 2, partition 3. This guy can again have partition 1, 1. I'm just naming it such
Sure.
Partition 1, 2.
Okay.
So Service Fabric was, think of it as in the design of the Service Fabric, the statefulness was ingrained. And even this, so partitioning, in its, you can say, a very innate thing does not really apply to stateless because it's about partitioning your service. And if it is stateless, what does it mean to partition, right? So think of it as if you approach it from a stateful perspective, you would be able to realize why do we need partitions. And then we simply adapted stateless to the stateful. So stateless also has a partition because it's the same construct that we have. With partition, since it is a stateful, and that so we say you have now replicas. So we have R1, R2, R3. So here you will have replicas. You have noticed that we call it replica, right? So replica means exact copy, right? And in case of a stateful, it makes sense and it applies because you need to have replicas, you need to have copies of your state. And that's why that helps you. So it's like redundancy, and you need redundancy to be for the availability, right?
Yeah,
Sure.
So in case of the stateless, we call it instance, and within a partition having multiple instance. So now think of it as if you want to run multiple instances of a stateless service, you can try to combine it in different way. You can have multiple partition with one instance, or you can have one partition with multiple instances.
Okay, we'll jump into that in a second, but let's discuss stateful first. So one thing you said was service fabric is architected for stateful applications. So that's something we've talked about before when it was initially built for consistency and for reliability.
Yes,
Sure.
So when we first architected or thought of the application model, we designed for stateful services.
Yes.
So one of the questions Charles threw out right at the start was, why should I do stateful or why should I do stateless? So what is your one sentence answer as somebody who's worked on this for a while for?
So that will depend on the requirement and design of the application.
Okay, so but what is that one key requirement?
So does your service needs to remember what it was doing if it fails over?
Correct.
If
Okay.
it needs to, then you need to be stateful. It does not, then you
So why couldn't I send a signal out to Cosmos DB and store that information?
So then you're saying, when do I need to be has a locally persisted state
Yes.
as compared to persisted state, right? So the persisted state could be remote as well as it could be local, right? So it will depend on multiple factors. So if you are really looking for very fast, performant read and write, definitely nothing will beat what you can do from your local SSDs, right?
True.
I see it so generally nowadays the network bandwidth is quite good, right? And you don't have a very sharp SLA on on read speed. I mean, you can always refer to having an external store. But if you want to be really awesome availability, so the way I would recommend is to have your hot data locally and your cold data remotely. So how it helps is if you are seeing that for whatever reason, right, any service can go down and not behave well, right? So say the network is not behaving fine, I'm not getting the response from my external store in the SLA that I have. So if I have already cached local data, I can read it from there and then respond to my customer. So it depends on what your application needs initially.
Amen.
So I mean, another thing to think about here is the moment you externalize your state, you're also increasing the points of failure effectively, right? Because now you're creating another dependency on the network hop.
Agreed.
So by localizing your state, so this is persistent state, but it's locally persistent state. But we also have the ability to persist state in memory, which is also obviously not something you'd be able to do if you were to externalize your state. So really there's two main, if I could say, you want to store state, you can store state in memory or you can persist it. If you persist it, you can persist it locally or you persist it externally. The first two in those cases, which is you need in-memory state or you want to persist it locally, are why we really have stateful service fabric
Actually,
services.
in fact, even the bigger challenge with the remote stateful is, so if your service writes something, right, writing remotely is, you need to ensure that at any given point of time, you have only one writer present, right? So in our stateful, since we have replicas, then we have a role as well, right? So there's a writer and reader, so you have only one master at a time.
Okay.
And that is controlled locally in your service. But if you're writing remotely, it may happen that your current primary failed over, current master failed over. Service fabric chose a new master for you who has now the privilege to write. That can also again send another write. So there could be two writes in flight on the network. At the destination where you're writing, that has to be resolved that the new primary or new master is the only one that is able to make change to your data.
Okay.
That gets complicated with with remote writing. So your destination where you're writing, that needs to be aware of how to make a decision and differentiate between who is the current latest primary and which write I should allow to go through.
Awesome. And with the replication, with our replication implementation,
Yeah, we already
we guarantee it'll be present
Yes.
in a
Yep.
quorum of
And a
nodes.
quorum of replicas. Okay,
Quorum of replicas.
so now that we've decided, let's say, okay, we've figured out what it means to have a stateful service.
Yes.
So this is the architecture of stateful service. You told us you got partitions. Partitions are based on sharding, which is just for your data. Say we're just discussing one partition.
Yes.
So walk me through what this is. Why do I need 3 replicas? Is 3 how much I should be going for every time? And you just talked a little bit about roles. Let's dig into that a little bit.
So you need replicas for availability, right? So I think even before the distributed systems, we had our RAID levels in the disk, right? So you try to take a copy of it to keep it as a backup, right? So think of it, this is like a live backup, right? Which is always in sync with your main primary. So the reason you need replicas is for reliability, simple. Other thing is availability, right? Availability does matter, and that's one of the things which people often ask, why cannot I have multiple instances of my stateless service which belongs to the same partition running on the same node? That's because we want to enhance our availability. What if that node goes down altogether? All your replicas or instances will down, right? So Service Fabric in its very initial design says that I will place each of your replica for the same partition on different node. And then on those nodes will also belong to a different fault domain. So that I can increase the probability that all your replica will not go down at the same time. And so the decision is taken to ensure your availability. And that's why you cannot have more than one replica of a given partition on the same node.
And these replicas you mentioned have a role. So you talked about writes, and you've also mentioned the word primary.
Yes. So the only difference in the stateful and stateless comes where, in case of the stateless, there is no state, so there is no reader-writer conflict, right? So there is no role required. In the case of the stateful, you need to have those roles, right? And in the case of the stateful, you need to also provide availability of the data, not just of the service as well, right? And that's why you have to put them on different nodes. So that's where the stateless and the stateful differs. In Service Fabric, you can think of that. This design is primarily fits very naturally with the stateful that is required. Now think of it as stateful. Being a stateful is an extra capability that is being provided. You can always make a thing which is stateful as a stateless, right? So take away the part that makes it a stateless, and then it will become which makes it stateful, and then it will become stateless for you. So what you take away, you take away the reader writer thing. You take away the who has the write permission and who has the read permission. So you say there's no role, there's no primary or secondary, and that's when it becomes stateless for you.
And what's the mapping between read, write, and primary? Is primary responsible for both reading and writing, or can you set a separate, like active secondary as a reader and things like that?
So then it depends when a replica can perform read or can perform write. So there are situations where even primary cannot perform a read. It depends, what's going on. So the combination between the role and then read write, it's kind of a table which has multiple combinations. I think one of the talk that you did with Prameya, he covered many of those.
Yeah.
So so that lies in his domain basically. But I can quickly.
That was the talk with AP.
Yeah.
Yep. So you have.
He called him by his full name. You see, we all call him AP.
So it's much easier to say. Okay.
So you have roles like primary and secondary, and in the read you have various different combinations. So you have read aloud, write aloud, wait for the configuration pending, right? So
Correct.
there are certain cases where you cannot allow the read to happen, and there are certain cases. So it's not tied to a role. It depends on what state the replica is in at that point of time.
Perfect. Okay, so that's cool. Now let's switch gears back to sort of stateless. So we've got the same architecture on this side, the exact same sort of perspective of partitions and replicas. But now we want state. So you said, fine, we're going to do stateless, we're going to remove the roles. There's no primary, secondary, there's no read, write, lock. What does this mean now? So are these now instances?
Yeah, that's instance.
Okay, so then why do we have a different name for them? Why don't we just call them replicas for a stateless service?
So we call them instance, right?
Yeah.
That's why we don't call them replica because they're not a copy of each other, right? In terms of the state, and that's why we call them instance.
So they're all able to do the same thing concurrently and aren't necessarily sharing or seeing the same data.
And that's when we say that having multiple partitions in your stateless service does not really serve any purpose for you. And then we say that you should have a partition and then have multiple replicas of that partition. So think of it as it provides extra layer of flexibility. If you really want to have multiple instances of your stateless service on the node, you say you can have multiple partitions because it interplays with the how we place the replica, right? Our placement and load balancer. And that's where so it's an interplay of two things. How does partition get placed on which node? So combining the two, you can achieve whatever you want to do, with the constraint that for a given partition, whether it is an instance or a replica, we will never place more than one instance or replica of a partition on the same node.
Or in the same FD, if we can avoid it, basically.
Yeah.
So this is interesting. So this is something to point out because we get this question a fair amount, which is, why can't I put 10 of these containers or 10 of these services on the same node if I declare them in this format where they're all instances of the same service? And if you were to ask people on our team, if you were to Matt, for example, he'd say, why do you need to put 10? Just put one and dedicate more resources to it. Like, it doesn't, why would you put, because when people think of more instances, as Hasibur said, they think of availability, but you're not gaining availability by adding instances to the same machine, because when that machine goes down, all of your instances go down. But you're also saying that I can now trick service fabric maybe. So in the case that I had an architecture where I wasn't doing it for availability reasons, but maybe I was doing it for concurrent threading or like handling multiple processes at the same time. So some of the demos I worked on, for example, so my one for Ignite, where I wanted to do machine learning, and I was just doing a simple stateless task to look at an image, do some processing, and pop out an answer. I wanted as many as I could on the same node. I wasn't doing it for availability. I was just doing it for as many as I can get. So in that case, I wanted to have more than one instance per node. And you're saying the best approach to do that now is adding multiple partitions.
Yeah, that's the only approach you can use if you want multiple instances on the same node.
Theoretically, I could also use the same service type and create a new service, right? So,
Yes,
I could just remove this part and just copy this over and over and over, and they're all within the same service type. Why would I prefer partitioning over doing that? So
partition is static in nature, so it gets written in the stones. So once you say I am creating a service with 100 partition, it will always be 100 partition. You cannot go back. You cannot increase it, and that's also it's called static scaling and dynamic scaling. So with partition, you have to think what would be my maximum possible use of my service in future, and then you would dedicate that many partitions. Initially, those partitions, they may not be eating any much of your resources. They would be kind of more or less sitting idle for you. As you onboard more users and more resource usage of your service, they will become active for you. In the case of the dynamic, what you do, you have another service which is responsible for creating services on demand. So you can create service and you can delete service, right? So that becomes more like your registrar or index manager. So that knows the list of the services that are in the cluster. So when it sees, oh, I am getting 5,000 more user requests and my existing services are not able to process it, so I will go ahead and create one and then direct all the traffic towards that guy. So that's a dynamic way of doing things. Or you can say, I know that maximum number of copies of my service that I will need is 100, so I will go ahead and create 100 partition. The pros and cons is that it's very difficult to predict future. That's an NP hard problem, right? Predicting feature. Other than that,
too bad. Too bad.
It's NP complete, right? So
I predict the future. What are you talking about?
That's right.
Yeah, I just know what's going to happen.
But that's interesting. Can we just kind of just talk about dynamic scale
for a second? Yeah.
Because I actually had somebody ask me at Build, because for some reason they put me in the booth.
For some reason.
And I was telling these guys all kinds of crazy things about Service Fabric. But the one person had an interesting thing, and that is, I would like to be able to dynamically change exactly what you were just talking about based on real-time current conditions. Yes. And once I detect that I need more partitions or I need more replicas or whatever, I can just make some API calls.
Yeah, so that's where it becomes important. So only cons is that you will have to write another service that is kind of the keeps track of what all services are in the cluster.
The watchdog.
Which one to delete.
Right.
Which one to create.
It's a service manager.
Yep. So for example, our own SFRP service that we have today, right? Every time you say us create a cluster for us, we keep track of that cluster, right? You say delete the cluster, we delete that cluster. So the service that is there, that is keeping track of. So as we get more requests, we will need to, like in the new product that we are shipping, what do you call it? Service Fabric mesh.
Yes.
Right? Yes, in the mesh.
Which is exactly what you're working on.
Yep. So in the mesh, we need to, so in the background, we are creating clusters, right? Depending on, so we can always create and delete those, right? So there's a service that is sitting on top. And then, so it's a very, I have seen many customers who have this pattern. Many times, anytime you allow a new user, so for example, say you are doing some professional thing for your services, right? And you are dedicating each service for your user. when they log in, you create the service, they do the stuff, and then when they log out, you just delete the service. So, I have seen many.
Pretty interesting.
That is it's like a disappearing task force.
Yep.
I like that model.
Yeah, it's actually really smart.
So that means, in this case, what I took away from this is, now if I'm somebody who wants more than n instances of a stateless service where n is the number of nodes I have in my cluster, I'm better off actually adding multiple service instances of the same service type, because I don't want to predict the future.
Other limitation with the partition is every partition, even if you have replicas, you cannot have more than number of nodes. So your number of replica or instance in your partition cannot be more than the number of nodes.
Correct.
But if you're creating services dynamically, you're not limited there.
Right. Because you can just create a new service of the same service type and again go all the way up to n.
Yes.
Interesting.
I can also create multiple applications.
Correct. So that's what I was going to say next. Is you talked about service type being a blueprint, but we also have one more level of abstraction about this. So imagine I have a service type that has this service instance. It's got one partition, and these are instances. This is a stateless service. Above this, I have another type, which is the app type. Why didn't I abstract on the app type and say I'll have multiple applications of the same type, each one of them has a stateless service with one partition, one instance?
So if my offering is such that, for example, take example of SQL Azure, right? So every time you create a database, it's actually a service behind, right? You say, I want a new database, they will spin up a new service for you. Say on top of that service, I also want to provide some data mining service which reads your database and gives you really useful insight on what you have in your database, right? So then it becomes a collective offering, and you would want to bundle them as an application, right? So in that point of time, it's a new application for you every time, right? You say, oh, some new user came, I will create another application for that user. And when you say, oh, I'm done with my database, I don't want to use it anymore, you will go ahead and delete it, right? So SQL Azure does it all the time.
Sure, interesting.
So basically, the application kind of guarantees you isolation, right? Application level isolation.
And that's where the parameters become very useful. So if say you have prime customers, and then you have free customers, right? So you want to constrain them by resources, and that's where you have exactly same model, same memory, something, everything same. You want, oh, this is a prime customer, they should have dedicated CPU, dedicated RAM, right? So while creating the application, you can provide what parameters you want to provide your application, and you can do that exactly. And then you say, oh, this is a free customer, I have 100 free customers, but I will limit them by like 4 GB of memory. So then you accordingly provide your parameters, and that's where it becomes very useful. So it's like a class which has a constructor that takes set of variables and input, right?
And you can
so based on the input, the state of the class object will be different, and that's how it's like you have a type of your service or application, you input onto that your parameter, and then the object of your application or service that comes will have a different state internally, will have a different resource governance internally.
Really interesting stuff.
So from a hosting perspective, since you're well experienced with that, what is the difference to service traffic hosting, whether this is a stateless or a stateful? Because in the service manifest, I've said that it's stateless or stateful, so service traffic should have knowledge on which one it is.
So hosting does not know anything about a stateless or a stateful. All it knows about that, since I am a host, I would make sure that my guests have a good time. For hosting, the guest is basically your service objects, your service replica. So hosting, what it does is make sure that wherever you are hosting yourself, like you're hosting yourself in a container or you're hosting yourself inside a process, I will make sure that process is up and running. I will make sure that container is up and running. That's what hosting takes care of. Now you can have multiple services living in this, the way you can have multiple friends living in the same apartment, you can have multiple replica living in the same process, or you can have multiple
shared process model,
yes.
Yes.
Or you can have exclusive, right? You say, oh, I want my own apartment on Airbnb, right? So you say, okay, I will give you a dedicated process. So we have two modes, right? Where we say, for a given application and a service type, we will start your service process once and all your replica of this service type, right? So it's slightly complicated. So you can service type have service type. Service type can have instance 1, instance 2. Every instance can have partition, and every partition can have replicas, right? So all the replica that belong to a service type. So that means for all the partition, all the service instances of this type, they will live in the same process because the boundary is the application. So every replica for a given application, they live in the same process or same container. Other mode is every replica gets its own process. So what we say, every time a replica is needed to be placed on a node, we go ahead and start a separate copy of your container or separate copy of your process, and your replica is the only one living in there. This again is so the multiple replica process is a advanced scenario, right? So for example, every time you create a process, you have to allocate resources, right? You have to allocate memory and other stuff. But in reality, people, when they approach, they think that this exe is my service. But in reality, it's not the exe that is your service. It's the code that runs inside the exe, right? So you can have multiple copy of your services within the exe running, rather than having multiple exes running if you want high density and if you want maximum utilization of your resources. But the challenge there, so think of it as, say my service is some code, right? So this code is represented by a class A.
Yeah.
One way of doing it is you have service process 1 exe. And you have service process 2.exe. You can have object 1 here of class A. You can have object 2 here of class A. This is one way of having 2 instances of your service, right? Other way is, hey, I don't care about the separate process. You have one process here, put object 2 here as well. This is another way of doing it. And this saves your resources, where you have more than one code of your service or replica of your service or instance of your service sharing the same process. The challenge here, you have to be really good developer and coder here, because statics here, you will have a static that will be access to both, right? So you have to make sure that you do not step over each other's foot. So if this guy corrupts some memory, this guy will have a hard time. If this guy is not using locks properly, this guy can have. So that's where, so if you can handle that level of detail, make sure that you are writing awesome code where none of your replica have their own defined boundaries, right? Then this will save you more resource, right?
Sure. However, doesn't it also mean, more goes down when that process goes down?
Yes. I, as a developer, see that if my process is going down, but it is not supposed to go down, there's a programming problem, or the underlying platform problem, right?
Sure.
A process should not go down unless you need to, right? So the thing is, when you start, you're going to start saying that, okay, to reduce the chances of collective failover, I will put them in the separate processes.
Yeah.
But as you make your code more robust and you are really focused on saving resources, you're really focused on spinning up the replica, bringing the service very fast, then you say, okay, I will start going more dense.
This is great. Awesome.
So think of it as this is all advanced scenarios, and that's why in the service fabric mesh, what we are seeing. So what happens is, in my interaction with the customer, they say that, hey, all this is awesome and good, but this is too many options for me. I'm too hungry. Give me something simple to eat so that I can feel good, right? And that's what they say. Oh, this is awesome. Service type, application type, this replica, that replica. Hey, here is my exe. Tell me how can I deploy and run it, right?
Right.
And that's why. And we have heard from many people. And that's why I think the service mesh is trying to bring up with a very simplified application model where you just talk about the service instances, and then you get started with the service fabric, get your stuff going, and as you learn about the product and you are dealing with the more advanced scenario, that's when this is good to learn and then implement.
So I have a question to sort of extend on this. So we talk about these things a lot. We call them SRPP and MRPP, correct? So it's a single replica per process, multi-replica per process.
Yeah.
So what you drew before was SRPP, where you had like 2 little processes, and then you said, okay, I don't want this, I'm going to put into that, and I'm getting more packing density. Do you say that because now these 2 guys are sharing the same memory and CPU, and that's why they can balance and sort of pack up that much? Because theoretically, what I also could have done is I could have given half the same amount of resources to each and said I'm getting the same packing density, right?
Yeah, that's a very good point actually, in terms of the resource governance, right? So the operating system today, it does not allow you to provide constraint of the resources at an object level within the process. So when you're combining it, then again, it's like these are good citizens, right? They're not eating up each other's allocated resources. So if you fear that, or if you're not sure they may eat up each other's resources, then yes, I mean it's a good idea to have them in the separate process. By default, I would recommend starting the separate process because this is a high-level scenario to play with. Think of it as if you're a new programmer, C# is an awesome because it will take care of memory management. But if you want to deal with your own allocation, deallocation of the heap, you need to be very sure what memory management you're following.
Exactly.
Similar kind of stuff here, resource management and all.
Right.
These has to be, trusted replicas. Definitely. Then that's an important point. If you really want proper resource governance and resource constraint, then yes, it becomes easy to have every replica in its own process and they are capped on the resource usage.
True.
So this is part of the noisy neighbor problem as well, that one of the reasons why people even start using containers in the first place is to avoid scenarios like this where you end up running too many things in the same process, and then it's like, oh, this process has gone overboard, I need to shoot it.
Yes.
And when I kill it, I kill too many things, which is sort of what you were saying. And it becomes very hard to identify within that process what is the thing that's being abusive that needs to be pulled down. So I think the best practice sort of takeaway here is until you're absolutely sure, stick to single replica per process.
I would say, in fact, until you have a solid reason for it, don't go for this one.
Don't go for this.
I would not advise going for this one. And I don't think you will need it unless you're writing an enterprise scale service which really wants to optimize on its COGS and on its cost, operating cost, on resources consumption. This is an advanced level scenario, and I would not recommend going.
Okay,
this
sure.
far.
I mean, it's just like you could, and people do, write service fabric services in C++.
And sometimes people do
Right?
it.
They're not even using C#, so they're doing much more advanced things.
Yep.
Yes.
In fact, they might even be writing their own replicators,
Yep.
right?
Yeah, like
So-
SQL loves this thing, and I think the density and then the scale at which they are operating is just awesome.
So, but I appreciate that you brought this up because we actually hadn't talked about that before.
Well, yeah, and one of the reasons we don't get to talk about it as much is because when you go into Visual Studio and you create a new service, it by default puts you into one of the modes,
Exclusive
right?
process.
Yeah, and it says exclusive process.
We have made that as default.
Yeah.
Because
That's smart.
that's the.
It took us a while to get to that,
Yes.
actually. It used to be the other way.
What I've seen is the by default, it's kind of you think that this exe is my service, which is not very intuitive when you come to the service fabric world, where your service is your object that runs either inside a process or inside a container, right? And so initially, it's if you have one replica inside the process, and then both work together, right? Because then your exe effectively becomes your service.
So I got another sort of scenario for you. So one of the things we talk a lot with users, but also in industry in general, is this concept of a blue-green deployment. So blue-green deployments are basically two identical deployments that are of the same sort of code, same service, or almost identical, where one might be a new version or sort of like the next version of the previous. And we do these for basically either increasing availability or realistically it's reducing the risk of downtime, where if one goes down, you can whip swap or you can sort of direct your traffic to the other, or in the old cloud services days, it's kind of my new versions come out once it's tested and ready, I'll move all my traffic here, and then this becomes my copy of that until I'm ready for V3, and then V3 brings it back, sort of thing. So I'm thinking about I've got app type, I've got service type, then I've got my service within the service package is the one that has the code in it, and it's got the code config data that you talked about. So my data is my data is intact, my code is the one that's changed. So config and data haven't changed, code has changed. I want to do blue-green deployment, so I want to have these two identical services, but I have V2 basically, so they do the same thing. I want to deploy my second one, and over time I want to move all my traffic over. I don't want to do the traditional service fabric rolling upgrade, but I want a blue-green deployment, and this is becoming more and more of a requirement in the mesh world, where people, since they're not seeing the underlying infrastructure, they don't think about rolling upgrades. They're like, no, I want to have this second thing up, and then I just want to swap to it. So in that case, I could have abstracted it on several levels. I could have had another service type, which could have been service type V1, service type V2. I could have had, I could have used changes in config to actually keep the same service type even, or I could have had a different app type with two app names, or I could have two entirely different app types.
Yes.
What would you recommend?
So generally, by default, as the designer of service fabric, a given instance of an application cannot exist in more than one version. That's the design we have.
Right.
Again, note that given instance of an application cannot be in more than one version at the time. So you have basically two dimension of, so you have your app instance name, right? App instance name, which generally you would have seen it will be something like fabric, called my app.
Yep.
And then on top of that, you have another thing, version, right? You can make it V1 and V2. So if you just differ in binaries, basically it's kind of different version, right? What you can do is version actually applies to your type. So you can have application type in multiple versions. You can definitely have application type in multiple versions. So you can have same application type, and you can have it in version 1, you can have it in version 2, and version 3. So when you provision your app or you upload your application type, right, you always tell which version you're uploading.
Right.
So what you can have your application type, which is basically you're referring to a set of binaries by some type and combining that with the version. So basically application type plus version is effectively different binaries that you're pointing to, right? So you're saying same application type, version V1 is some exe. Version V2 means same exe but something different. Again, V3 is something is different. So what you can do is, since the name of an application or an application instance has to be unique throughout the life of the application, whenever you have a different version, you can create an application with a different name.
Correct.
And you can use the naming such that which includes the version itself, and then okay, this is what it refers to.
Yeah. So the core requirement there really is basically saying I need the same app, but 2 different versions running concurrently.
Yes.
So what you're saying is have the same app type, upload 2 different versions to the image store, and do app instance 1, app instance 2. They can run at the same time across the cluster, and they point to different versions.
So here in this table, probably it will become like for every row, you can have a single instance of every row, right?
Correct.
So then you can always create, different names, right? Or for every row you can have multiple names. So and that's how you can, whatever way you want to name your application, and from the name you can always parse which type it is.
What's the benefit of doing this versus having different app types?
Different app type is then a different identity completely, right? And that's where you may not want to be easily able to correlate. It will require you to repackage the stuff, right? Because it's a different identity for the cluster itself, the cluster manager that we have. So then you will have to repackage, change the manifest and other stuff. In this case, you don't need to do anything, just upload in different versions, and then when you're creating, you will say, okay, I want to create in version 1, or I want to create in version 2.
But there is a trade-off there then, because if I want isolation across those 2 different concurrent versions, it might be interesting for me to explore app type. But if I want ease of upgrade with least number of moving parts, then this makes more sense.
So you upgrade a given application instance, right?
Right.
That's what you upgrade from. So an application instance moves from version V1 to version V2. That's the upgrade.
Right.
So the smallest entity of upgrade in Service Fabric is your service, right? So you can just change one of the services in your application, and then you can upgrade the application. So application is like a tree, right? So you have your application, and then that will have services, right? Service 1. Service 2, service 3, and then say they have code packages 1, code packages 2. So think about it, any node get touched in the tree, the top level version will change, right? And then you can upgrade it to the new. So the moment you touch, you say, oh, it has become to another version, and then I need to just upgrade to that.
Right.
So application in itself, every application is isolated from other application. So for this guy, if you create 2 applications of this application type name and then version 1, it will become
isolated. So then really there is no good reason to differentiate based on app type, because that just creates additional overhead from your management perspective. Mm-hmm. Your best approach is to stick to the same app.
It will help you to avoid the repackaging and other stuff.
Okay.
Sure. You should reserve that for when you actually want to host multiple apps in your cluster that aren't the same.
Yeah. So one other thing that I wanted to sort of touch on while we have you, since again you have experience with hosting containers and this whole thing. So we talked about code packages. We also previously talked about code config data. When we talked to Rajit, we spoke a little bit about what the data package is, what the config package is, and what the code package is. And today a lot of people are approaching Service Fabric. Most of them don't use the data package because they don't need this initial seeding data for a service. So they think mostly about config and code. And when they think about code, if they're written in containers, there's an interesting sort of mapping that exists from a container image to what a code package looks like. Because in Service Fabric, we treat code package as what gets deployed, and that code package references a container basically that gets deployed. But you can also have multiple containers inside the same code package, right?
No.
You can't?
So a code package always refers to either a single exe or a container.
Okay. So there's always a one-to-one sort of mapping between code.
So Service Fabric abstracted the notion of your host of your service. So host could be an executable, it could be a container, and in future if we come up with something new, a virtual machine, right?
Sure.
It could refer to a virtual machine that has something inside it running. So it could refer to any entity that can have your service binaries running or service code running.
But now I could have n number of code packages inside a service.
Yeah, you always have that capability.
So basically you can have as many containers as you want.
So generally the use case is you have one of your code packages, which is your main service, and then you can have sidecar or any helper service or
Correct.
any agent that runs and does the stuff. Think of it as all the code packages within a service package. They lie in the same trust boundary. So they will share all the resources. They will have access to same environment variables, access to all the certificate and resources. So they are within the same trust boundary, and all the code packages, they should cooperate with each other. You cannot have. So for example, if I need to host a third-party application within the same service package, so think of it as CP1 is my monitoring service, and then CP2 is some third-party guy. That's not a good idea because they are within the same trust boundary. So if it is a non-trusted code, that's not a good idea. You have to host it in a separate service package.
And if they are in the same service and they're in the trusted boundary, they're also co-located on the same node.
Yes, they're always co-located. So all the code packages, their life cycle is same. They share the same life cycle and same physical location as well.
Yeah, that's the app. I just zoomed in on the app tree.
Yeah.
I mean, that's one entity.
Yeah.
That's the entity that you should consider.
So I think the minimum unit that gets activated and deactivated or comes into the being and goes out of is your service package, and all the code packages. So if when this guy comes into being, all the code packages come into being.
Okay.
When this guy is bring down, all the code packages go down. So they share the same life cycle, all the access to all the resources and everything.
So big learning for me here then is service is really the key boundary in Service Fabric, because your application is sort of your abstract group of services that have the same life cycle sort of thing. Your code packages are all dependent on the services life cycle. The service is the one that you really upgrade, manage. You make decisions on whether or not it's stateless or stateful, what resources it has access to, what that sort of boundary looks like.
Yes.
And sure, it might be part of, I almost think of an upgrade, I think of an application as like an upgrade group of services, which is like
So
what services need to be.
Application is just a logical entity that helps you to group the service.
Correct.
It's like a tagging, right?
Yeah.
It's like tagging, and then whatever common thing that they share, you put that as a logical entity.
Yeah.
It does not really exist in the real. So when you go an RDP to a node in a cluster, all you see is a exe, your service exe running, but behind that there's a full tree of management layer.
Absolutely.
All right.
So there is the application boundary, right?
Cool. Thank you so much. Well, I got one last question for you. You've got one thing that you can recommend to anybody about anything. What are you going to suggest?
In context of what, like,
Literally anything.
I mean, the plate is too large, right? So if you're talking about different parts of the life or just in software, right?
Whatever you like.
I mean, very basically, be passionate about whatever you're doing and be very honest. That's what be frank to speak and be honest in your conversations, and then just love the thing that you're doing.
Amen, man. Thank you.
Cool. Thank you so much for your time, man.
Thank
Really
you.
appreciate it.
Awesome.
Learned a bunch.
Thank you.
We did.
Yeah. So
Killer.
we've got a few more, coming down
I hope so.
the pike.
Good.
Apparently. And looking forward to getting more stuff out there.
Right on, man.
Thanks,
Thank
guys.
you.
Thank you
Cheers.
for making that. Thanks, Hasibur.
Thank you.